Hey folks, this is Joe at Creekside Cabin Games, checking in to tell you what I've been working on for the last week. We have put grinding in the game, grinding rails. Currently there are no grind tricks, for example, nose grind and tail grind. It's just one general grind. Let me show you how it works. And then we can get into let me show you how it works in gameplay, and then we can talk about how it works programmatically, because it is both one of my great achievements in programming and one of the greatest hacks. So you can see a couple of things here. We attach to the rail, and we have the meter above us that shows our balance, and that stays upright all the time. When we're on the rail grinding, we can boost, but it messes up your balance, and I'm not sure how I want to address that. Let's see. You can only grind if you're not upside down, which isn't really much of a feature. Actually, I didn't really show it there. But if I were to do a kind of a flip and try to grind, that doesn't work. What was really challenging was getting the multiple segments together, and having the character turn at each one and kind of keep the balance as a single. Right, you got to keep the balance through the whole grind, and changing direction would, if it were actually physics based, it would throw your balance off. But I've come up with a way to keep it consistent no matter what your angle of the player's moving at on the grind bar. And I'm going to try to go through and explain how this works as best I can. I don't think that it's a perfect solution. There's some stuff I'm really unhappy about, but I think it's a good example for making compromises and making something work in your game and kind of making it good enough, and thinking about, are there ways that I can design around this shortcoming in order to move forward. So the first thing we want to look at, and I know we probably haven't dug into the game object we're using here that the player controls, but on the player there's three physics objects. There's a snowboard, a body, and a grinding snowboard. The body and snowboard work together in the kind of the default mode when the player's gliding along the ground and jumping and doing flips and doing tricks. But for grinding, I decided I wanted to have a different rigid body that was a little easier to control for now. I may switch it back eventually, but so there's a couple. Let's look at all the classes involved here and how they work. There's kind of two things going on. There's the player control, and then there's a grind rail manager for each rail. Actually, let's go look, before we jump in, let's go look at what a grind rail looks like. It has a left and right point, and it has one or many segments, and within those segments are rigid bodies, which I think actually may be superfluous at this point. I had done that for a collision problem. I'm not sure it needs to be like that. Anyhow, left point and right point, terrible hacks. This needs a better editor, but we'll see why here. Alright, so we got a start grind ability, and I would say familiarize yourself with Corgi Engine if you wish to understand the code I talk about a little bit better, because I use a lot of their stuff. But in the grind here, we're going to check each update frame. We're going to check if the player is allowed to grind, basically, based on some criteria. So is the Brody controller colliding with grindable? That's set in the snowboard object, because if we look, snowboard has a script. It has a snowboard script, and one of the things that does is set is colliding with grindable. Is the timeout over since the player quit grinding? I think, again, both of these lines are probably superfluous, but things are working right now, and I will do a cleanup, but I'm just really excited to have this working and ready to show it off. And then this check is just make sure the player's basically between, mostly upright and not upside down. Upside down players should be able to grind yet. Maybe one day we'll have some upside down gravity and let you grind that way. That seems like a lot of work to put in, and upside down gravity never really pays off for me in games. It's kind of like cute for a little segment, but I wouldn't want to build a mechanic around it. It's just too, my brain doesn't enjoy that. I don't enjoy the challenge, that type of challenge. Okay, so that's the first thing. Oh yeah, and then of course when oh crap, I need to. Oh, okay. I just put pause escape conditions. Anyway, so if they can grind, if they can't grind escape, they can grind. If they click the glide button, then we start grind, and that flips us over to the Brody controller, which is the next place we need to talk about. Let's start grind. And I'm not going to read through all this, but basically it's swapping feedback containers around and animation containers so that we can keep the same model container for animation in both when either the grinding snowboard or the snowboard game objects are active. And then we'll talk about some of the other things. It sets the velocity for the grinding snowboard basically of the incoming velocity scaling the Y down. So if your character's flying downward, you want some of that energy to go into their forward grind, just because that's what a player expects in a snowboarding game, from my experience. So we're just kind of pushing forward a little bit with the Y speed of the snowboard that's about to begin the grind. I don't think that this equation is exactly right though to like transfer all the energy, but it seems to work good enough. Because what I should really do is like determine the angle the player's at. So if the grind rail's slightly downhill, it should be not directly to the right. If you can see this, basically this new vector declarations, everything, all this goes into the X value. So this should be a normalized vector in the direction that the player begins grinding. But that's, I'm trying to think if I can even do that. I mean, of course I can. It's just going to be a mess because I have some coupled code here, which you may be thinking in your mind, how did it get this way? But anyhow, we basically take control away from this rigid body and put it on this rigid body. And then deactivate this snowboard and this body, and everything goes over here to the grinding snowboard. Alright, what's next to talk about? Oh yeah, the camera target moves as well when we swap the game objects. And the charge sprite, the little red sprite that expands before you jump. Alright, then there's, within the grinding snowboard, there's two physics objects, the rail connector and the rail balancer. The rail connector's job is to stick to the grind bar and when the grind angle changes, to change the angle of the player, but keep them connected throughout. So doot, doot, doot. And then the rail balancer, the rail balancer's job is to keep the player upright. So if you can remember Tony Hawk Skater or whatever, anytime there's a grind in a game, you got a kind of a meter that you got to keep even. So yeah, real quick, I'm going to go back to grind, because that also has the control for if they are grinding. If the player's grinding, use the horizontal input to add torque back and forth on this on the rail balancer. So yeah, the rail balancer is made up of a hinge joint That's really it. To kind of stay upright, and it has a min and max angle. When those angles are hit, the player loses the grind and falls off, and the grind is ended. The sticky balance time is how long after you begin the grind does the balance become free, because you want to give a little forgiveness to the player when they hit so they can orient themselves to the change. 0.4 is very forgiving. I'll probably lower that. Let's see. The balance bar is the visual component minus the blue part's like the dial in the balance bar. You can see that's the balance bar indicator. So this object has to be manually spun to compensate for the spin of rail connectors. So if we go look at rail connector, part of its job is to find the rotational difference that's is about to make and apply it to the balance bar. So if you imagine your guy is grinding and then we grind downhill, right? Here's the balance bar. We don't want the balance bar to shift with the guy. We want to rotate in an opposite direction so it stays on the screen horizontally for the player, because that is, it's a HUD element for the player. And believe me, it was skipping around and it was very disorienting and very hard to keep your balance. So really proud of that solution. Alright, and then we can look at the grind rails themselves and some of the code involved there. If y'all have any questions, please put them in YouTube comments. I'd be happy to make a video explaining anything I've done here. Let's see. So we want to look at the actual the rail code. So each grind rail has a grind rail segment that's just got some, basically, these are read-only fields used by the grind rail manager for managing where the player is on a grind. The grind rail manager So one of the problems I want to solve is what happens if you grind up? What happens if you're grinding and then you hit and then the rail changes to upwards, but you don't have enough speed and you come back down? I think it'd be super silly if the player went up the hill and came back down and glided back and kind of glided into a valley, right? Eventually, because that's what would happen, right? You wouldn't have enough momentum to get out either way. So just the moment that you go backwards and hit a piece of like a bar the bar segment, there's many bar segments. So once you go back to a bar segment that you've touched before, it lets you fall. You lose the grind, right? But I do want you to be able to go backwards on a given segment. So all this does is basically mark segments as having been used in a given grind, and after the grind's completed, we go back and we deactivate all those segments so they can be used. It allows for grinds to go both ways too, so we could potentially have half-pipe type levels where you just kind of go back and forth left and right in order to score as many points as you can. I didn't want to have to worry about like giving my grind rails a left or right attribute, or moving left or right attribute. One of the huge challenges I ran into, I wish I'd recorded it, is I have to show you one more thing here before you can understand this. If we look at the player and we look at the collider used to connect to the to the rail, this little green collider is always used to connect to the rail. And no matter what you do, if you were to say, let's go look at the rail again, because here's the solution I tried to use. I basically said if you get to a corner, if you get to a place where we're changing directions, rotate the player and reattach them at an appropriate point where the collider will jump onto this, right, and go down this grind rail, etc. And it did. It worked for one. It worked for one really good. But by the time you got here, it had just got all messed up because the place, it just doesn't work right. there may be like there may be a mathematical method for getting the turn and placement correct. I could not get it. So I hacked it a little bit and basically just changed. I didn't move the player, I just rotated them and changed the direction of the slider joint used to attach the player to the grind rail. I don't think I mentioned that. Yeah, it's pretty key. The rail connector uses a slide joint with a changing angle in order to kind of traverse the different grinds. And it looks pretty good over 3 or 4 grinds. It doesn't rely on the exiting of the collision anymore to let go, which was another problem that I don't think I can articulate exactly how it manifested, but I knew. One, I was just concerned about it. And 2, I was getting weird behavior, so I tried to eliminate as much shit as I could. So, yeah, the one last piece of anatomy for the grind rail is the left point and right point. And this is a hack that I'm not proud of, but it gets the job done. Basically, if this rail is active, and a character's X position is less than this dot or greater than this dot, the grind ends. And that's really the only thing we'll do. Either that happens, the player's moving too slow, the player hits a rail they've hit before, or they lose their balance. Those are the 4 ways you can lose your grind. But yeah, having it do something on collision exit was really messing me up, because you can imagine if we move down here and we snap to this one, we've just done a collision exit. So I had to do a bunch of checks to see, is the player still connected? And it just concerned me. Having on trigger exits and enters, this is my really first big deep dive into that. I'm going to recommend against using them as often as possible. Obviously they're necessary, but try to come up with strategies to eliminate those if you can. Like, I should have just started with raycast. I knew I should have, but I was being lazy, and it just probably cost me an extra day of work. So anyhow, thank you. That's what's going on here. Next week, I think I'm going to work on enemies. That's been my goal for a couple weeks now, but I really wanted to get grinding in just because it's more fun. It was fun to play. The game is more fun now. Enemies are in a place where I don't know how much more fun they're going to get. They're just going to be more polished. So let's look forward to seeing a video next week about how I enhance the enemies. Thank you all, and we'll see you next time.